Good morning, everyone. Thanks for joining us again today on this pretty day in Tennessee. I think we're going to get up in the 60s, right?
Yeah, it's going to be really warm today.
Yeah, which is pretty rare for January. Usually we're in the 30s and 40s.
Exactly.
But yeah, it should be really nice today. So I hope everybody else has got a good weather as well. Or if you don't have good weather, I'm hoping you're actually watching our webinar.
For sure. Staying warm.
Yeah. So again, I've got the famous Ray Gore. Today we're going to go over some 16S meter testing.
Yes, sir.
Let's get into it. Next week, keep an eye on your emails because we're going to be doing a metering quiz show. I won't be here for that, but who is going to be here is going to be John Jones. He's going to be here as our game show host.
Okay.
I'm going to have Ray Gore as one of our players. Steve Hudson, head of our engineering, he's going to be one of our players. And we're going to have one of you guys. So when you register, we're going to randomly draw a person that's going to come in. We're going to stream you in. You don't need to physically be here.
That's cool.
We're going to stream you in, and you're going to be one of the players on there. So we have 3 players, and you get to test your metal against Ray and Steve. So it should be a really good time. And then you're going to have, obviously, John Jones being our game show host.
The game host.
So
yeah, game show.
He's going to be our Bob Barker.
Okay.
So it should go really, really well. So I'm excited about that one. And then we're still working on that field trip. Just as soon as that weather gets a little better, we're going to go out. We're going to do some filming. I want to do an overhead. I want to do a substation. So we can go out there, do actual field testing so you guys can see it rather than something we got simulated in the lab. Okay? So that should be a good one as well.
That'll be fun.
That'll extend out probably 3 or 4 webinars, I would say,
Okay.
that we'll have that. All right. So what we're talking about today, we're going to go over kind of the overview of a 16S meter. We're going to talk about probes you recommend to be able to test it. You've got a variety of probes you can use to test a 16S meter. We're going to talk about the difference between a 15S and a 16S. A lot of guys ask about that because some people say it's, 15S, 16S. There is a difference, by the way, between the 2 meters.
Yeah.
And so we want to make sure that's clear. And then we're going to talk about the difference between the 16S and the 16K, or maybe you ever heard of a K-base meter. We're going to talk about that. And then we're going to do some troubleshooting with Ray on some mirrors.
For sure.
All right. So looking at the wire diagram, you've got 3 lines coming in and 1 neutral phase. Notice on a self-contained meter, your voltages and currents are separated. But here on a self-contained, you're coming into 1 line off of the distribution side. Coming into the meter, coming back out, there are no CTs in service. So an equivalent to this would be for a transfer rate would be a 9S, right?
Yes, sir.
With 3 CTs.
Yes, sir.
So with the self-contained, you've got the advantage you got here with the self-contained 4-wire Y is you've got cost. It reduces your cost, but the cons are is that you're limited in the amount of current you can supply. So it's CT rated, you can go all the way up to thousands of amps, but with a self-contained, you're all limited. We'll talk about that. So a 4-wire Y is 3-phase. I'm sorry, a 16S meter. It's a 3-phase 4-wire Y. You've got basically two typical voltages. You've got a 120 volt, 3 120 volt sources, 120 degree spacing. And so if you had a voltmeter, what you would do, if you had A to neutral, you measure 120 volts per leg. And if you went phase to phase, like A to B or A to C, you would measure 208. 208, yeah. And that's coming off the distribution side. So you're measuring that coming into the meter. Now, if you had a 277 480 tap, similar, you would phase neutral would be 277, or you would have 480 volt phase to phase.
Yeah.
In this vector diagram here, we're showing is at unity power factor.
Yeah.
Now, also on a self-contained meter, you've got a class, and they call it on the meter here. They call it a CL. So it'll be a CL or class. That's talking about the max current this meter can handle. So this is an example of a 2S meter. So it's a class 200, CL 200, similar to a 16S. So you've got a selection between a class 200 or a class 320.
Yes, sir.
Now, obviously, a class 200, it can go up to 200 amps max, right?
Exactly. Yeah.
Class 320 can go up to 400 amp max. Now, we'll talk about that it's a class 320 goes up 400 amps, but we also have seen problems with this, right?
Oh, yeah, for
Okay,
sure.
so we'll talk about that. And with something Ray and I highly, highly recommend, if you have a class 320, and especially if you have a 277 480 volt, make sure you've got a bypass switch on that meter. What happens if I don't have a bypass switch?
Yeah, it's going to be very dangerous. I would follow all of my utility recommendations when you remove a meter, or if you're doing any type of service on those meter cans. I would make sure I follow my safety guidelines on that, because you've got a lot of current and voltage there possibly. So that's a must. Make sure you follow the safety guidelines.
Yeah. So if I don't have if I had a bypass switch to actually shunt the current as I move it out, what happens if I pull that meter out directly?
It's going to follow. The current's going to follow you.
Yeah.
So
Arc flash possibility, right?
Yes.
Very dangerous. I'm sure you guys have seen it on your safety videos. An arc flash is real. It will big fireball comes up.
You don't want to do that.
When those jaws don't collapse when you pull out the meter.
Yeah. You don't want to do that at all.
Yeah.
Make sure you follow those safety
The higher current, the higher the voltage, the higher the possibility of an arc flash
It's
happening.
an arc flash for sure.
Let's talk about some of the probes we got. Jared, let's switch this camera real quick. So right now I've got, what we're using here are what we call MN353 probes. And those are 200 amp max rated. Now if you had a class 320, this may not work, right?
Right, that's correct.
But a lot of the 16S meters are class 200, so these type of test switches these type of clamp-on probes will work fine. The other option is using an SR752, and switch back over here to Ray, Jarrett,
Yes.
and talk about those,
You've
Ray.
got the SR752s, good for 1,000 amps, and you've got a direction of current flow here. So all of our probes have these arrows on the side of the probe, so you need to make sure that that arrow follows the direction of current flow. So, but they work really good in the meter can. And if you're not sure of what you're working with as far as current, if you have both of these probes, just take your voltmeter and measure current. If you have a regular clamp-on voltmeter like what we've got here,
Shut the camera.
and you got a regular voltmeter like this, you can just clamp on the wire like that.
Yeah, before you actually make your connection.
So that's just something that you need as many tools as you possibly can to help you with that. But if you're not for sure of what probes to use, just clamp on your current so you can verify how much current you've got in the meter can.
Now, a lot of our customers that buy their PowerMaster product, they've all got flex probes.
Yes.
You usually buy a set of 3.
Yeah, and flex probes will work.
Flex probes is another great option. You can go up to 3,000 amps, so
3,000
way beyond what the 16S would see. But you've got, the nice thing I like about the flex probes is you can get inside those real tight
Right.
16S cabinets that I've seen. This one, the one we have here is, I'd say it's fairly medium size. I've seen one that are tight, that are right around the base of the meter itself, and there's not a lot of movement. So a flex probe will work perfect because you can kind of rope those in, wrap it around, and get it.
Exactly.
And the thing that Powermetrix really advocates is this customer load test. We like to be able to test under actual
Real world
conditions rather than
conditions.
pulling the meter.
Right.
Now you can still pull the meter, and we've got a product called the 4 Series where you can actually pull the meter, plug it in, and run a full load power factor light load test. That's fine, but we like to recommend doing a customer load test because if, let's say you have a customer complaint, they're going to want to see it in socket, right?
Yeah.
They're going to see, well, I don't know what your magic box does when I plug it in there. I want to see it here in my socket. So
Exactly.
this is why we kind of advocate this method.
And then you can tell the customer, go turn something on so you can measure.
Turn your AC
Yeah.
on. Yeah, let me see.
Yeah.
So let's talk about the difference between a 16S and a 15S.
Ooh, that's a good one, Chris.
So GE or Eclair now, these come out with this fits-all meter, which I think Eclair still has a fits-all meter, right?
Right.
Okay. So they've got on their faceplate, they've got a 15S/16S meter. And what they say is it can support both services. But back in the day, probably in the 80s, I would say, they had these 15S mechanical meters and 16S mechanical meters that, even though the same socket could support them, but they meter differently.
Yeah, they
So
have different voltages too.
back on the PowerPoint, Jared, if you look at the left-hand side, that is a 16S meter. Notice that your A, B, and C potentials or phases reference a neutral phase there on pin 7. Now on the right, different story.
Yeah.
So you still have 3 elements of the meter, and it looks identical as far as element-wise, but it's wired totally different. Notice that both A and B are referencing each other. They don't have a neutral phase. And then you've got only a C reference on itself. And we'll explain why they do that. So with this old 15S mechanical meter, what they did is that they would support a delta service. You can still support this on a 4-wire delta. They still call it a 15S, but I'm not sure why they do that. I think that's a misnomer.
Yeah.
So it had, at that time, it had 2 voltages, phase to phase. So you had 240 volts VAB. And then you had your high leg, which is your 208, or if you had 277 volt, it'd be 277 volt coming in. So it's a very specialized service. If you guys remember, if you're older meter techs, you may remember the transfer-rated version, which was the 8S. The 8S mechanical meter. This is kind of what it supported. But again, nice thing about it, the 16S socket supports both meters, a 15 and a 16.
Which a lot of the meters actually say that too. It is say 16/15 on there.
Yes,
so.
right. And let's talk about the difference between a 16S and a 16K or 16K base. So on the left, 16S meter, and what does the S stand for?
Socket type.
Socket type. So you use a meter socket. You can actually pull it in and out. On this one, we actually have a lever bar that actually, once you open it, the jaws open. I can easily remove the meter, insert it back, close the jaws back, and it's got its tight seal.
Okay.
K base is different. So K-Base was made by Landis and Gear.
Yep.
I don't believe they make them anymore, but there are still lots of them out there in the field.
Probably with adapters. They went to adapters with that type of
Good question.
there.
Yes, our local utility, I know well because just about all the light commercial in my hometown is using K-Base.
Yeah, I've seen
McDonald's, Taco Bell, they all got K-Bases.
Yeah.
And so they had an AMI project they were working on that came through about 4 or 5 years ago. And during that time, they had to upgrade their K bases. And so what do you think they did?
They went with the adapters.
Yes. So the adapter was basically, it was almost like converted to a CT rated site.
Yes, sir.
And so they put these split core CTs on the K base bars to be able to step the current down, because those 320, 400 amp meter, 400 amp services that meter could not handle it. So they had to be able to step it down to get something that's much more realistic. So tell me about, I've had some experience with K-Bases. What is your experience at K-Base when you were at Knoxville Utility Board?
My biggest things was seeing them to where they weren't torqued correctly. They do come with little torque wrenches back in the days. And I've also seen to where, let's say this customer is saying that their service is 380 amps. You come back, they've added a couple of things, freezers, whatnot. You come back, take the lid off that meter and look and see that the legs started to discolor a little bit. So you know it's gotten hot on that particular phase. So you know they've increased the current. So, and of course on the meter it says, I think 420, I believe.
320.
320.
Yeah, I think K-Base
some of these old ones had 600 amp.
600 amp.
So yeah, they had 600 amps on them, and so that was the key to it all. And I think they dropped it down to 480.
Yeah, okay.
So,
I think, if I'm not mistaken, because Ray and I had this question about the class ratings on 16Ss, we had to verify that there was a 320 amp class, which we thought there was. My suspicion, I believe, the K-Base probably was the first self-contained meter that had a class 320.
Yeah.
Would you agree with that?
Yeah, yes, sir.
Okay, I think so too. And then I remember you telling me a story about you would be able to open up the K-Base cabinet, and you would just by telling the color of the bus. No, I'm sorry, color of the meter terminal itself.
Of which leg you had the problem.
Yeah, what color was it?
It was kind of a grayish, bluish color.
Yep.
And kind of a dark, and you can tell because it's either caused by too much current or where they didn't torque it down correctly. But it was,
too much
a telltale
resistance
sign.
then.
Yeah, it was a telltale sign.
So either too much resistance or just overburden. Well,
Yeah.
I guess overburden on the actual meter terminal itself.
and it was about ready to go.
And tell me, how did you test those in the field?
Well, I'd pull my Powermaster out and test it. It's what I would do, and verify current. And of course, I had flex rings, so I'd either use my flex rings or my SR752s. So, and I could tell you right off the bat, I can give you instantaneous readings, and I can tell you it's probably a good chance to pull that meter out.
And if you had to pull the meter out, what did you do?
That required a whole lot. They actually have bypasses for those little, they look like little rakes, and you install them and you pull the meter out. But in a certain condition like that, I'd recommend them upgrading the service.
I have seen if you have a test board, which I think this battery people had a test board in their shop, I've seen that
adapter
they have to use to be able to mount that to a test board. I'm sure that's kind of a little bit of a burden.
Yeah, and it was hard to keep it stable too. You had to prop something underneath it to keep it from
like
falling
a block.
out of the,
Gotcha.
Keep it from falling out of the socket.
Gotcha. Okay. So that's a big difference between a 16S and 16K, right?
Yeah.
So again, Lannis Gear made this. This meter was great back in the day.
Yeah.
Because it could handle up those higher currents, and it makes it nice and easy as far as being able to test on a customer load, because I got a lot of space I can use. But I think as some of the socket-based meters have kind of helped out the technology, it's not as prominent as it used to be.
I think that was just cheaper, right? Just cheaper instead of a CT installation.
Yes, it was always more cheaper. Yeah. So for the 16S meter, we recommend using the two style probes. 353 is probably the best one I would recommend using. If you don't have that, or if it's too tight, go with the flex probe.
Probes, yeah. And they're dependable. I've used them for years with no issues. Just make sure you have the arrows going in the right direction, and you should be good.
Yep. For the K bases, I've only got one real option, which is the 752s.
Yeah.
Those work extremely well.
They do.
It could use flex probes, but I like the 752s because it's so easy to clamp around those conductors on that K base. Yeah.
There's one conductor there, and you can just clamp on and go with it. So it's so much easier.
Okay. So we kind of got over the overview. We've gone over the difference between a 15S, 16S, got the difference between a 16S, 16K. Now it's time for troubleshooting with Ray.
All right, let's do it. I love it. That's what y'all were laughing at. Okay, I got it. They've been laughing about it all morning, and I didn't know what was going on. But that's fine.
So Ray is going to go through the setup process, setting up the Powermaster, hooking up your potentials, hooking up your clamp-on probes, and we're going to run a normal test here right now. Take it away, Ray.
Take it away. Okay, so we've got I'm going to put one glove on here. You make it hot. Give me a 4-wire Y. That's what we're dealing with here, right? So what's the difference on a 4-wire Y and a delta? We just spoke about that. So what would be the difference? The difference is in voltage. We could take our voltmeter and measure to verify that. Mm-hmm. So let's go ahead and hook this up. Okay. All right. So before the presentation, I've already set everything up in the machine. The most important part here is check your vectors. That's the most important thing to do. Okay, so check your vectors. And again, if you're not sure how much current you're dealing with here in the meter can, pull out your clamp-on meter and measure current. But anyway, so we've got 120 volts on all three phases. And as Chris mentioned a little bit earlier, we've got 15 amps, and we've got that 120 degrees, right?
Mm-hmm.
All right, so let's hit continue. I'm going to hit previous and get out of this. And I'm going to do a meter test. We're not going to do an integrated site test. Of course, you can see in the upper right-hand corner, 16S test. I've already selected that. So we're going to bypass integrated site test, and we're going to go to meter test.
So why go to meter test and not integrated site test?
Well, because we're not testing the CTs.
Yeah.
We're not doing anything, okay? So my bosses want me to at least get 15, 20 meters done, self-contained, so I'm going to do a meter test. It's a lot faster. Okay, so we're going to do customer load. All right, so here's the cool thing. Let's say, for example, that you need to actually do a demand test on this. So you can actually do a demand test as well, right? So we can go up here and click that. And when you do a demand test, make sure that you're comparing whatever the meter's programmed to. So like if it's programmed to 15 minutes or if it's programmed to 30 minutes, that's what you use there.
Mm-hmm.
Okay, so we're not going to do a demand test, so we're going to take that out of there. Okay, and so what we're going to do is we verified the KT on the meter, which is 21.6. I've already put all that in there. And test time, 0 seconds. Test revs, 3. And again, everybody knows what 0 means. I'm looking for 3 revs, and I'm not worried about time. Okay? So I'm looking at my revs.
Quickly show, now that we're at the wiring diagram, quickly show your connections.
Okay, so let's go over the connections real quick. If we review the wiring diagram here, we've got 3 voltages and 3 currents, and SC means self-contained. Okay, so A phase voltage and current is here. Okay, B phase, same thing here. C phase is here, and we've got our neutral. Okay, so if you can flip over to this side here, meter can, you can actually see my voltages. A, B, C, and then I've got a neutral here, right? All right, so if you had a Powermaster, which I'm using a 3 series, but if you had a Powermaster here, you would make sure that that green ground, more than likely if you're out in the field, they might have a number 6 ground tapped somewhere, and so you connect that ground to it. If not, you don't see one, just go back up to the neutral. If you're using a 7 series or 5. Okay, so we're going to move on, and I'm sure that John's went over all of these probes here. Okay, so you know SVA, SVB, SVC, and SV neutral. And then all of these is in green, so that's the active voltages and active currents. Okay, so then we're going to, and then if you, here's a cool thing. If, let's say that you don't see a probe up here, you can just hit F1 and rescan probes, and it'll pull that up.
Yeah, so for example, let's say I forget to plug in my probe set and realize that missing probes, I can hit that rescan button.
Yeah, you can hit
right?
that rescan button to read the probes.
Gotcha.
Okay. So then we're going to say next, F6. Okay, and then we're going to wait for our meter to output a pulse. And the next thing that, while I'm out doing this test, I'm out in the field, the next thing I'm going to do is I'm just going to make sure the display looks right. Okay, see these indicator lights up here? I'm just going to make sure all of those say A, B, C all the way through. All right, and then I'm going to hit F6. I've seen some of these meters to where they don't accumulate in the display, and you won't even know. And they test good, but there's no accumulation on the display.
This is an Elster A1D, right?
Yeah, it's accurate meter. Okay, and that's good. So let's say, for example, that you see a result like 99.663.
Mm-hmm.
If you see any of those like that, you can move these around a little bit, because see how I've got it relatively close up here? You can kind of move it around a little bit to see if you get a better reading, because you're getting a stray fields from these other probes.
Uh-huh.
So that always works. So you can actually move this down away from that one, and then hit a retest and see if you get any better. I will say this, you can single wrap using the flex probes. I've got some flex probes here for you guys. You can single wrap those. So let's retry that and see what we get. So we've separated them now a little bit. We'll see if they get any better. Let's see. So let's say, for example, I'm out in the field, and let's say that I'm trying to attach my probes onto these conductors. Is it safe for me to move the conductors?
Move the conductors? Probably not.
Exactly. You do not want to move the conductors. Another important thing is when you're removing the lid off of these meters, try your best, to keep that lid stable. Don't have it leaning on one side. So it's a little better moving the probes around.
So if I had to go out there, if I had to do a troubleshoot call, and I realize this meter is out of specification, what are the steps I need to follow to make sure that I safely de-energize and remove the meter?
Well, the first thing I'm going to do is I'm going to talk to the customer and see if I could actually, again, follow your utility recommendations. But if your company will let you remove the meter under a load, then you can use your bypass handle there and remove the meter.
Yep.
So that's the most important thing. But some utility companies, according on the rated voltage, will require you to pull the jacks. Go talk to the customer, pull the jacks, or there's normally a main right there near the meter can, and they want you to talk to the customer first and then pull the handle, pull this handle, and pull the meter out.
Okay.
It's just whatever their safety recommendations is, I would follow. Because again, these little guys, they look like they're happy and safe, but they're not. They've got a lot of current going through them.
Yes.
That's 200 amps. Like you mentioned earlier, you might find some that says 320. And like them OK bases there, they could go to some of them will say class 480, and some will say 600. The older ones say 600. So, okay. So it's a little better.
So what happens if we go out there and maybe we find a problem? Do you want to simulate that real quick?
Yes, sir. Let's do that. Let's find an issue. Let's find us a problem. I'm going to set these on the floor.
You can't troubleshoot without a problem, right?
Yeah, we got to have something going on.
I mean, we didn't make that picture of you for nothing.
Texas Ranger, huh?
What do you mean make the picture? That's not Photoshop.
Jared, yeah. Jared did an excellent job.
Yeah.
He's got man of many talents.
I'm trying to figure out if John Jones was involved on that.
No, he's out of town.
Oh, okay.
By the way, John Jones is out of town. He's actually installing another one of our training benches. So we're super excited about that.
Which that's a good thing because a lot of us old guys, we're kind of seeing our better days. But these training benches, I was actually doing testing on this all last week, and I've learned a lot. And I love these things. I wish that we had them when I was going through the ranks.
Oh yeah, heck yeah.
And not only that, if you can move them around. I've moved this one from here to there to over there in the corner.
Mm-hmm.
So I like them. And, it feels like you're in the field when you're messing with them.
Oh, yeah.
It really does. So, okay, so what do you want to do?
I don't know. What's wrong?
Let's look here. So what am I going to do? So I pull up to the site, high bill complaint or low bill complaint, I don't know.
Yep.
First thing I'm going to do is I'm going to look at the transformers, get out of the truck, so I know exactly what I'm looking for, okay? What am I testing? Is it a 4-wire Y? Is it a 4-wire delta? So you look at the transformers.
Mm-hmm.
Next thing you want to do is you're just going to browse and look at the display of the meter. If your meter has these indicators on there, I see C phase flashing here. So what is that telling me? I don't know. So that's where I'm going to go to my Powermaster. So I'm going to put all my information in. And the next thing I'm going to do is I'm going to do a vectors. I'm not going to assume anything. I want my equipment telling me what's going on. So I'm going to do a vector. Ooh, okay. So what is that telling me?
I don't see C voltage.
You don't see C voltage. Okay, so I don't see any C voltage here. All right. Remember the meter display told us that we were messing C phase voltage.
Yep.
Okay, so the next thing I'm going to do is I'm actually going to measure and verify that that's what I'm seeing. By the way, somebody switched gloves on me too. They gave me a size small glove. So they're having fun today. Okay, guys, so the next thing we want to do is we want to figure out where is C phase voltage, okay? So when we done the test, we were assuming that A phase is on the left-hand side. So we're going from left to right, A, B, C. So what I'm going to do is I'm going to take my voltmeter here, And I'm going to find me a neutral. See if I can stretch in here and get that. Alright. And then I'm going to verify C phase voltage. Jarrett, you watching me?
Mm-hmm.
Okay, good. Alright. And I have 0 volts to neutral. I have 120 volts on B phase. I have 120 volts on A phase. All right, so that's telling me what I need to know. Okay, so more than likely, my next step is I'm going to look at my transformer and make sure that I've got the voltage. I'm going to check that as well. So after we get that done, let's go ahead and see what it tests at.
Okay.
You want to do that?
Sure.
Let's see what we're going to get.
I suspect registration should be okay.
Yeah. Well, let's see. Because how are you going to explain this, right? Hit previous, yeah. How are you going to explain this if you have a... Yeah.
Go ahead.
Okay, so what we're going to do, we're just going to do a regular meter test. I can't even bend my fingers in these gloves.
They're Jarrett's gloves.
Oh, are they?
Oh,
Okay.
the Powermetrix did tell you something.
Oh, okay. So this tool is actually doing exactly what the voltmeter did, right?
Yep.
Okay, so if we don't have any voltage here, then the next thing I'm going to do is I'm going to go up and I'm going to look on the pole, right? Okay, so I'm expecting probably a fuse barrel opened up or a damaged transformer.
So the nice thing about it, I can hit ignore and keep on going.
Exactly. So let's do that and see what we get. So that's a good thing, because wonder if the billing department is saying, well, how long has it been like that? Well, obviously in something like this, you know, they're going to be part power or something other like that. So they're not going to have their... Has anybody ever seen an imbalance phase on a 16S meter? I wonder if any customers have seen an imbalanced phase.
I'm sure.
Of course. See a lot of it. So it's going to take a while for it to pulse,
Yes, sir.
right? Okay.
One other thing too, so not much of a difference, but
No.
the big difference here is that you're lost in KW.
Yeah, so
That's what's
what
going on. So
yeah,
you got an
so-
element out.
Right, so let's look. Let's look. All right, so look here. This is what you want to look at right here. So you want to help the billing. You want to save that. You can
Yeah.
actually save that. And,
Kind of proves out right there
right, exactly.
that you got a bad element.
Right.
This simulation was really designed around. Think about those either older mechanicals or those single range meters they had in the field. And let's say I put this on a 4-wire delta, 3-phase 4-wire delta, nothing special about it. But what does that C phase have? It's got a 208 high
208
leg.
leg, yes sir.
So if I've got a single range meter, 120 volt to neutral, and I put it on a 208 volt leg, it's going to blow that C element, right?
Yeah,
So that's what we're trying to simulate here.
yeah.
Is a blown element on a meter that would cause the element to not short, but it causes it to blow out, and therefore it's not measuring that phase.
Especially on
accurately.
electromechanicals, if it was rated, if the voltage rating was 120,
Yep.
and you took that meter and installed it
208 high
on a
leg.
208 high leg, you're in
Yep.
trouble.
All right. Good
All
job.
right, hit previous there.
One more.
All right, let's do one more.
This one's similar but different. If that makes sense.
Okay. So if I was going to do a demand test, let me go back to that. If I was going to do a demand test, why is it important that let's say I'm out there and the meter is programmed for 15 minutes, but I run a 5-minute demand test. Well, you get in there and you turn it in, well, the meter's good. What did it actually do? Compare apples to apples. Run it for 15 minutes and see what it does.
Mm-hmm.
Instead of running a 5 minutes, in which, I've done it, but to prove a point, you run it 15 minutes the way the meter's calculated. If it's calculated 30 minutes, do it 30 minutes. I'm not saying set in the truck. Stay with your meter and make sure it works. All right, so let's see here. All right, so
Last one.
So here we go. First thing we're going to do, again, if your meter has any type of indicators on it, just take a look. All right, B phase. Okay, so it's telling me something. And then, of course, I'll check my transformers while I'm there.
Mm-hmm.
I'm looking at my hookup. I'm just going to make sure. This is saying B phase voltage, so I'm just going to make sure that, I didn't do this on the other one, but just make sure that my connections are good, in which they are. All right, so next thing I'm going to do what? I'm going to go in here and I'm going to do a vectors. I am not going to start that test. I got a tool. I have a tool. I'm going to use it. All right, so wait a minute now. Okay, so, look here. B phase voltage is gone. Look. Guys, there's no current. Chris, you're messing with me. There's no current. Okay. So, let's see here. So, if we have no current and we have no voltage, then is that telling me that the meters, what's going on here? All right. So I'm going to do the same thing. I could actually get my voltmeter out and measure voltage and make sure I've got my voltage down there, but I'm not going to have it.
Mm-hmm.
Okay, so y'all want to do it? Let's do it. Let's just do it real quick. Same thing. We're going to go to our neutral. Jarrett, you with me?
Over there.
All right. I'm going to go to B phase. And I have nothing on my voltmeter. I'm going to go to C phase. I've got 120 volts. I've got 120 volts. So I can actually go phase to phase. I have 120 volts phase to phase. So what voltage did you say I'm looking for, Chris? If it's a 4-wire Y, I'm looking for 208, right?
Yeah.
Okay, so we have a problem here. Okay, so if we have no voltage and we have no current, well, let's do this. Let's just verify. If you have this equipment on your truck, guys, use it. We're going to set our voltmeter to current. We're going to clamp on that lag. And I have no current going to this meter.
Nothing.
Nothing. Okay. So that will tell me something's going on. So what do you guys want to do? We've got B phase element. We have no B phase voltage and no B phase current. So I'm gonna check my transformers again on this one as well.
Yeah. So what could happen on the transformer stuff that wouldn't?
You could have a blown fuse on the transformer,
Mm-hmm.
just like I was saying on the other one. I guess the other simulation you were doing, you had it set up to where if we still have the voltage, more than likely you've got something going on in your meter, right?
Yeah, that's right.
Okay.
So this one, I think you're exactly right. So this is simulating an issue on the
Transformer,
transformer side itself coming
Yeah.
into the meter. It's not a
Yeah.
meter problem.
No.
Meter socket is okay.
Yeah.
This is something going on outside of the meter.
Yeah. So what we did was we measured voltage, we checked our current, we verified it with our Powermaster,
Mhm.
we verified it with a multimeter. Next thing we're going to do is we're going to check the transformers. I will check transformers every time. That once you do that, that could tell you that's off the list to check.
Yep.
Okay, so once you check your transformers, once you check that, that's it. You're crossing everything off your list to check. So you've done every single thing you possibly can to verify what the problem is with this meter set.
Cool. Good job.
Okay, so we know what's going on here, and you know what we're going to do? We can actually go here one more time, and here's a cool thing. Let me show you this real quick. You can actually, I'm going to get y'all, Mason. Go ahead. You can actually go stop, and you can actually save that and print that out in your report to show right here. Okay, so you have
No power.
no power, 0. So there's no voltage and no current.
Yep.
Current's actually right there.
And that can be started back.
And that can be started back, and that data is saved.
Mm-hmm.
Okay, so that's the cool thing about that. You can go, cool thing too is you can hit F3, interval, and then test period.
Yeah, test period, it will kind of help you with your demand testing you're talking about. You can actually let it run for 15 minutes and it will accumulate
While you're, yeah.
kW during that period of time.
And then you want instantaneous so you can see it. So.
Yep.
But we've used every tool that we can here to verify this service. So we're for sure of ourselves and we're for sure of our equipment, so we know there's a problem here.
Yep.
Okay.
I agree with you. All right. Good
All
job,
right.
Ray.
So
That's
where's
it. That's
my-
all the troubleshooting.
Where's my horse at? Jared?
He's out back.
Oh, is it okay?
Yeah. All right, guys, we're going to wrap it up. I appreciate y'all hanging out with us. Can I get the, yeah.
Any questions?
So don't forget, watch your emails coming from Jarrett. It'll come from, actually come from John Jones. So make sure you register for this one because we're going to be selecting the winner, the winner of the to come
Meter and
on
quiz show.
with your registration. So you don't need anything else, but just register for this next webinar coming up.
Got a question. Andy Ray says, if this was a 3-phase setup, but it was changed to a single phase and left as a 16S, would it meter correctly?
That's a good one.
If you have the program set as a 16S,
Well, if the meter is programmed, because it's going to show an error because it's missing B and C phase.
true.
I think it would.
the meter.
I think it would.
I think it will measure kW fine,
Yeah.
but the meter is going to give you some false errors.
Yeah. And that's where he would probably need to program it. A fit-all would work.
Yeah, if it's
But,
over.
yeah, but this type of situation, probably not. If the meter will, well, now you can actually turn those errors off in the program where it won't actually lock the program up. But what I would do is I would also verify it with my Powermaster. I test it and see what happens.
Mhm.
All I got.
Okay.
Oh, Jim B says, how would a 15S meter if the neutral on the pole was broken?
You wouldn't have that high lag.
You got
right?
no high lag. Yeah, that's
Yeah.
right. So you probably show nothing on C phase. You would still get your phase-to-phase voltages for VA/B,
Mhm.
your 240
But your
volt,
high lag will be,
but you had nothing on your high lag.
it'd be
That's a good question too.
floating, I guess you would say, wouldn't it?
Yeah, your vector diagram would be flipping-flopping all over
Yeah.
the place. That's true. Because there's no reference phase.
Mhm.
Now again, your VAB's got a reference.
Yeah,
That's
from
solid.
face to face. Both.
CV measure basically will be less than 2/3 because you got a high lag on your C phase. So that'd be quite a bit of revenue loss on that one. Good question.
They normally tie a single phase motor or something to that
Yeah.
C phase, like a single phase AC or single phase.
Motor
crank or
wouldn't run.
No.
They give you problems.
Yeah.
Any other questions? All right. Thanks guys. Thanks Ray hanging out with us.
Yeah. Heck yeah.
Yeah.
Enjoy. Always.
We'll see Ray and Steve Hudson again next week.
Next week. Okay.
With John Jones. He's coming back. So I'll be gone, but you get all the good guys coming back next week.
All right. See y'all.
Appreciate it. See you Tuesday.